All right, in this video, we're going to go through the basics of making a cam operation. So making a setup and then picking which operations you want and then processing your G code. So this is going to be a pretty simple one. So we're just going to do some simple one setup shapes. So like this bar, for instance, it only has holes going through, actually only one side. There's nothing on the top or the bottom. It's just this face that we're going to have to machine. Okay, so when you're going to run your cam operations, we have to change from the design workspace to the manufacture workspace. So change over to manufacture. I'm going to go back to my home view. And the first thing you always have to do is create a setup. A setup is what tells the machine where its origin is, and it starts everything for the cam operation. So up here, you can either click setup, go to new setup, or if you have this little file folder with the block right there, that'll create a new setup. So you just click that. So your machine, I'm going to click select and you pick the machine you want. If you've done stuff before, it'll show up there. So you have to make sure your machine is in there. So operation type, we're going to leave as milling. All of this stuff should be set as your default. But the only thing we're going to have to change is our origin, our workspace coordinate system. So see how here the Z is pointing up? Z is the direction that the end mill is going to work on the face. So we're not cutting anything on this top face, but right now it's aligned with the Z axis. So we need to flip that so the Z axis kind of points. Let me see if I can move this a little bit. So the Z axis looks like this. I need the Z axis to go up this way because this is what the piece is going to look like in the machine. Okay, and so to do that, you come over here to orientation. It should be model orientation. So if you design in Z up, if you make your thing in Z up and you're just doing one thing, it'll already be set up. But if not, you change this to Z axis plane and X axis. So I'm going to click that. Now it's asking me, what do you want your Z axis to be? The face. So I'm going to highlight this face, and this is the one. See how it's got the holes in it? I'm going to highlight this face because this is the face that I want to be pointing towards the end mill. And now it's set up. So if you imagine Z being the direction of the end mill on the machine, now it's lined up with the holes I'm going to cut. So now I need to tell it where the X-axis is. The X-axis is going to be the front of the machine. So our tube cutter lines up pieces like this. So I'm going to call this edge down here the front of the machine. So I'm going to click that. And now I have my Z and my X-axis set, but my X is pointing the wrong way. I want my X to point to the right because our origin, the way we do it in our shop, is our origin is always going to be the bottom left corner of the workpiece. So right now my origin is in the middle, but I need to tell it I want it to be down here in this bottom left corner. So to do that, down here where it says origin, we want to make sure it's model origin that's selected. I'm sorry, model box point that's selected because the model origin is different. So I'm going to do model box point. And then right here where it says model point, I'm going to click this box to turn on box point. Now it's asking me, where do you want it to be? So I can pick any of these points on here. You want to do the bottom left corner. So this is my bottom left corner, but I have three options. I have bottom, middle, and top. I want to be on the top face of it. That's going to be my 0. So the 0 is always the bottom left corner of the work on the top of the workpiece. And now I have my origin set. So my model is already selected. I'm not going to mess with fixture. We don't have fixtures. Stock, make sure you have no additional stock selected. So if you haven't made this your default relative size box, and then no additional stock, because we're not actually milling away any stock. And then I'm just not going to mess with part position or post-process. We'll post-process later. So click OK. And now my setup is done. And so it's good habit to always name your setups what it is, right? So this is the electronics rail. And because there's only one face, I'm just going to call it that. Okay, so now let's go do the operations. I need to bore out these holes. So bore is probably the most basic operation. So up here on 2D, you can either drop that down and go to bore, or if you have it already in your toolbar, mine is already set up because bore is used so much. I'm going to click that. So this menu pops up. The first thing it's going to ask is what tool do you want? So If you've used a tool before, it'll show up in here. So this is the one we always use for cutting parts, 99% of the time, I should say, is the 4mm flat end mill. So I'm going to click that, and it should be, yeah, see the preset is in aluminum. So you got two options. You got aluminum or plastic. So we're going to use aluminum, and then we don't have to mess with any of the speeds or speeds because that's all set up. I set that up in the end mill, in the tool library that you get. So you shouldn't have to mess with any of that. So I've chosen the tool. We're going to skip multi-axis. We're going to go over to geometry. And now I have to go pick the holes. So you can either, one by one, I can zoom in and I can choose every single hole. Or if you want, you can do select same diameter. And that will choose every hole that has the same diameter. So in this case, all these holes were, I think they're 0.201. So it's going to highlight all the holes. But you got to be careful if you use this sometimes, because if there's holes on the bottom, it'll think you want to go all the way through. So you need to, if this is going all the way through, you need to select only same Z top height. So it only does stuff on this top face. So I'm just in the habit of doing that. If you do select same diameter, always do only same Z top height. So all my holes are chosen. I'm not going to mess with any of the other stuff. Let's go to heights. So if you notice, my bottom height, the default is set to negative 0.02. And that's because if I look at this head on, we zoom in a little bit, I want this going to, well, that's 20 thousandths of an inch below the bottom of this piece, right? So if I just made it go through to here, maybe this is off a little bit. It doesn't drill all the way through. But if I go 20 thou further, if I make this come out a little bit further, I know that it's going to cut through the piece. So let me show you what it looks like if I put 0. If I just put 0, see how you don't see it coming through? And, you know, maybe you're off by a couple thou and you got to go back and drill all these things out. It's just easier if you add a little offset to the bottom. And I set that as my default. If you want to set defaults, right click there. I'm sorry, just click there, save as user default. So negative 0.02 is my default for basically every operation. So I'm just double checking that this is right. You shouldn't have to mess with clearance or retract heights. So let's go to passes. Passes, my angle that it ramps down at. So you can kind of, let me shift this a little bit. You can kind of see how it does a little, let me zoom in, how it's spiraling around there. That angle is what you're changing on the ramp angle. So for aluminum, I usually leave ours at 5 degrees. It's kind of conservative, but I like keeping our end mills in one piece. So we're not going to change anything else on here if this is at 5 degrees. If it's not, change it to 5 degrees. Make sure stock to leave is off. Linking, you shouldn't have to mess with anything in linking. So really the only things you're changing are the tool, the geometry, check your height, check your ramp angle. So now I'm going to press OK. And then I'm going to kind of go to a home view. Well, I got to click home now. And now there was my part. So when I click on the setup, it shows me where my origin is. And when I click on this, it shows me what's going to happen. So it's kind of sideways because this is our origin. So when you do it on the table, let's see if I can line this up correctly. When you actually do it on the CNC table, this is what it's going to look like that, which is what you want. All right, and so if you want to check it, make sure it's going to work right, come up to the top, actions, simulate, not simulate with machine. So we want simulate. So on mine, I have that on the taskbar. So let's go press play, and let's just make sure it does what we want it to do. So there's those 4. You can speed it up down here, make it go a little faster. There we go. So we got all our holes. We don't have any errors. I'm going to exit the simulation, and this one is done. So when you're finished, you can save it, and then to export your G code, you'd have to do what's called post-processing. So you come up here, you can either go setup, create NC program, or you can just put this in the toolbar, click NC program, and then you can go through and create your NC program. I'll do another video about that, but that's basically how to make a setup and the operation. So let's do another example really quick, faster than this one. Here's a bracket, and this has a bunch of different operations. So we're going to not do just a bore. We're going to have to do a pocket here and then a contour to cut it out. So I'm going to kind of run through this one a little bit faster. So here we go. We'll change to manufacture, and then I'm going to create a new setup. And my setup, I'm going to go orientation, Z-axis, and X-axis. I'm going to choose this as my Z, and I'll make this my X. So I've got my Z and my X selected. Let's go to my box point. I'm going to choose the bottom left corner and the top of the material. So that is my origin now. So I almost forgot. Let's go to machine, and I'm going to choose my MPC-125. And everything else should be good. I'm going to check stock, no additional stock. Okay, so there's my setup. Okay, first operation, let's do the bores. So I'm going to click bore. I'm going to go, there's no tools in there, so I'm going to do my 4mm end mill when it pops up in this menu. And make sure it's aluminum. So it's aluminum, that's good. I'm not going to mess with any of that. Geometry, let's go pick one hole, and then we'll go select same diameter, only same Z top height. All of my holes are selected, so I'm good. I'm going to check my height, negative 0.02. So I always double check by clicking right. I want to see that it goes through, and they all go through. Let's go to passes. I'm at 5 degrees. Go back to heights, linking. Everything looks good. I'm not changing any of those. So I'm going to press OK. I'm going to click home again. And now I've got my bore done. So next, this hole right here is too big to do a bore, because if I tried to bore this, I'd be left with this big chunk on the inside. It would leave a big circle, and that piece might come flying out and hit somebody in the face, and that would not be a good time. So instead, we're going to pocket this. So a bore is only good for up to twice the diameter of your end mill. Our end mill's 4mm. That's like 0.16 inches. So we can only bore a hole that's up to 0.32. Instead, you need to do a 2D pocket. So a 2D pocket is something that cuts like larger geometric shapes. If you had a weirder shape, you could do an adaptive clearing. But for most of the shapes, you'll use a pocket. So I'm going to click 2D pocket. This one's a little bit different. So I've already got my 4mm end mill because it came from the operation before, so I shouldn't have to mess with that. It's already set for aluminum. So I'm going to jump straight to geometry. So it's asking me to select the pocket. So I'm going to choose the bottom of the piece, not the top, because if you choose the top, that's where the bottom of the end mill is going to go. It's not going to cut anything because it's not actually going into the piece. So I need to click down here to make sure that the end mill goes and traces out that circle at the bottom of the piece. Make sure these are turned off. Any other pockets you have, you can select those. Let's go to heights. Again, bottom height, negative 0.02. So let me look at it from a right view. I want it to cut through that, right? So here, let's go to passes. You want to make sure stock to leave is off. When you do a pocket, we're not doing finishing passes on the CNC. Make sure either this is set to 0 or you turn stock to leave off. You always have to turn that off, because otherwise it'll leave a little bit of material. So like in this case, let's say you had like, let's say you had like 5 thou left, 0.005. This hole is going to be too small because you left stock in the way. So always make sure that's turned off. And then I'm going to go to linking, and I'm going to turn, well, you can lead, it doesn't really matter, the lead ins and lead outs, because it'll do it in here. Lead in and lead out just offsets it so that it goes in at an angle. You can leave it on if you want. Ramp, again, make sure the ramp is 5 degrees, and that should be good. So I'm going to press OK. And it's calculating the toolpath, and there's the pocket. So see how it goes in? I'll run the simulation so you can see it. So you simulate, and then I'm going to turn this speed down a little bit. Goes in, and then pockets out that inside. Looks good. Okay, last piece, I'm going to cut the shape out with a contour. So this is from a big piece of metal, right? I have to actually cut the outer shape out. And to do the final cutout, you always use a 2D contour. So it's under 2D. You can go to 2D contour or just click it in your toolbar. So same thing. If I've used the 4mm end mill before, I'm just going to leave it alone. It's already in there. It's already got all my presets. So I don't have to mess with that. So I'm going to jump straight to geometry. Again, just like pocket, I'm going to click the bottom of the contour that I want. So that's the shape that I want to cut out from the big sheet of metal. And then something we're going to do is put tabs on it. So tabs, if this thing tried to cut it out from a sheet of metal when it got to the end, there'd be nothing holding the piece in and it would go flying out. It would catch the end mill and go flying at somebody, and again, not a good time. So if we do tabs, tabs will hold this part in. So I set mine up. I do tab shape as rectangular. I do tab positioning by number of tabs, and then I turn my tabs per contour down to 0. Right? And then I'm going to go to a front-on view where it says manual tabs. I click that, and I can go place tabs here. So I'll put 2 on the top. So I'll do 1 there, and then I'll do another one here, and then I'll mirror those on the bottom. So I'll do 1 here, and I'll do 1 here, and then I'll do, because this has this thing over here, I'll do 2 tabs on this side. So I'll do 1 kind of right there and 1 right there. So that should be enough to give it enough grip to the metal to allow for this side to cut on its own. If you wanted to, you could add another piece here. You just don't want to put tabs near these little corners because that's going to be hard to cut out. So if you look at it, let me go back to the home view. What a tab is, it's going to leave this there so that it stays connected to the metal, and then we can come back later with a hacksaw or something and cut it out. So there's my tabs. Let's go to heights. Again, bottom height, -0.02. Go to passes. I'm going to make sure stock to leave is off. I'm going to go to linking. And for 1/8 inch thick material, we're not going to do any ramps or anything like that. We're not going to do any multiple depths. If we were doing thicker material, we'd do multiple depths, but we're not going to do any of that. We're just going to plunge into it and go. So I'm going to turn on lead ins and lead outs just to make it a little bit cleaner on there. And then let's press OK. And let's see our path. There it is. So I'll show you what the tabs do. Here's the simulation. Let me shift this up a little bit, and now let's run the simulation. So you can see how it skips that little part. So it jumps up. It's going to leave that little part connected so that it doesn't fall out. That little chunk right there is going to be connected. And then let me change the opacity so you can see. Yeah, so there's my workpiece, and this is going to be connected. You'll cut that out later. So exit simulation, again, good practice. I didn't name my setup. I should do that now. So I'm going to click that once, and this is called the 3rd stage bracket. So I'm going to name it that. So now I have my setup, and I have my 3 operations. And again, we'll do another video. Once you have this, you're good. We'll do another video talking about like post-processing and G-code and stuff like that. But you could post-process your G-code from there. And that's how to make setups, basically on flat things, right? Remember, always start with setting your coordinate system. Imagine that's the bottom left of the machine. If you set the coordinate system correctly, the rest of it's pretty easy.